Okay, we're going to look in this video at some examples of using the derivatives of the trig functions that we just learned. And we're going to combine those with the derivatives of the functions we already knew about and the rules we have for derivatives of combining functions. We have product rule, we have quotient rule, and we have a rule for a sum of functions. We also have a rule for a constant times a function, finding derivatives of all those things. So the first thing that you should probably notice in this problem is that I've got variables in both the numerator and denominator. So I'm going to really need quotient rule here. So you want to make sure you have that memorized. Okay, so hopefully you already have that memorized. We're going to apply that in this problem here. And so I'm going to basically write down a structure for quotient rule here. I really suggest that you do this when you're at first learning this. Students often get lost in the middle of the problem, and so if you can just kind of set the problem up for yourself, I'm going to set up some parentheses here. The derivative of the top times the bottom minus the top times the derivative of the bottom. And you can use shorthand notation here to remind yourself what you're doing, all over the bottom squared. Bottom squared. Okay, so I just made some little notes to myself here, and then I'm just going to now worry about the individual derivatives and fill those in. But the notes that I made to myself in red there are really just trying to remember quotient rule as the structure for the problem, and then we'll fill in the details with the derivatives that we know. Okay, so the derivative of the top function, that's going to be the derivative of the tangent function. You should have that memorized. That's secant squared of x. And then times the bottom function, just the bottom function, not derivative of that, just the bottom function, minus the top function. Again, that's just the function. And then times the derivative of the bottom. So on the bottom, we've got an easy power rule, derivative of x squared. That's the one where you bring down the exponent and subtract 1. And then plus derivative of 5 is 0. So I don't really need to write that plus 0, but you want to think about derivative of the 5, the constant, all by itself is 0. And then on the denominator here, I'm going to have the whole just bottom, the original bottom of the original problem, squared. Okay, so at that point I have my derivative. Even you would want to include the parts that I have in red there, the parentheses and the minus sign and the square on the bottom. When you do the online homework, you can leave it like this. When you're doing homework that you might turn in to me, if I don't say simplify, then you could leave it like that. But there will be times where you'll want to simplify it, so we're going to just kind of talk through what that might look like just to make sure you're clear about how that would look. Okay, so on the numerator here, I've got a secant squared of x, that's one term, times something that's two terms. So I could distribute through that secant squared of x, and when I do that, I'm going to have secant squared of x times x squared. I would probably write the x squared out front of the secant squared of x so that it's clear what the secant applies to. If you put the x squared in the back, it's a little unclear about whether the secant applies to all the x's or just the x right after the secant squared of x. And then same thing when I distribute that secant squared of x times the 5, I'm going to put the 5 out front. Okay, so that was just from doing a distributive property on the first part of the numerator before the minus sign. And then on the second part of the numerator here, I've got this plus 0 term, so I don't really need that, plus 0. And then what I have here at the end is it's all just one term. I don't have any distributive property really to use. I'm just kind of rearranging that. I'd probably put the 2x out front so that it's clear the tangent function just applies to the x and not the 2x. And then all over the denominator squared. Alright, so on the denominator, x squared plus 5, the quantity squared, you could leave it like that. Really, that's about all the simplifying I can do on this problem. I don't have any like terms that combine. After that, I don't have any canceling that can really happen, so I can leave my answer like that. The only other thing maybe to consider doing would be to expand out the denominator if you really want to do that. So you would have to FOIL out that denominator though to do that. I'll just write that in really little right here. Okay, and remember, if you FOIL out that denominator, that you're going to have that middle term there. So don't forget that you're really FOILing that denominator and you've got some like terms to combine. So what I have in the box is perfectly fine for an answer, and actually probably how I would leave the answer. What I have below that is okay as well. Don't forget you have a numerator and a denominator. All right, let's look at another example here. Okay, so we see that we got a sine function on this one. There's also an exponential function. The other thing to pay attention to is where are the x's here. I've got an x inside an exponential function and an x inside a sine function, and those two things are times each other. So this one's really going to be product rule. So when I think about the product rule, I need to make sure I think about what are my two factors. So my first factor I'm going to group as e to the x, and then my second factor is sine of x. So those are the two parts here of product rule. And then just like I did with quotient rule, my advice would be to kind of set up a structure for yourself so that when you're finding this derivative, you don't get so lost in the details that you forget kind of the overall structure of the problem of the derivative here. So when I do product rule, I have the derivative of the first function times the second function plus the first function times the derivative of the second. And you may have memorized that in a slightly different order. As long as you've got the correct terms grouped together, you'll end up okay here. Because you can switch around the order of multiplication and addition and end up okay. Okay, so the derivative of the first function. So derivative of e to the x. Oh, that's the easiest function ever because it's its own derivative. Derivative of e to the x is e to the x. All right, then times just the second function, so my sine x, plus the first function, just leave it alone, and then times the derivative of the second function. So here's where I need to remember my derivative of my trig function. So you should have those memorized. Derivative of sine is cosine. All right, and so there's my derivative. I could leave it like that with the parentheses and the plus sign in the middle, or if I want to clean that up, I could rewrite that as e to the x sine of x plus e to the x cosine of x. Or I might notice there's a common e to the x factor on both those terms, so I could factor out an e to the x. I probably actually would not factor that out. I probably would leave it separate, but it's fine to factor it out. Any of those things that I have here would be correct answers. They're just different forms of the same answer. For online homework, it should recognize that you're just typing in the different form of a still correct answer, so any of those would be accepted. For homework you're turning in to me, any of those would be fine. They're all really just different versions of the same thing. Okay, we're going to look at one more example here. Okay, so in this problem we've got x's in a few places here. We've got a bunch of trig functions, but the other important part about this one is that I also have a sum of functions. So when you do these derivative problems, it's important to pay attention to how the functions are related to each other. Multiplied, added, subtracted, divided, however they're related to each other. And the nice thing about having a sum of functions, addition or subtraction actually, is that that allows you to chunk the problem, because that rule for differentiating sums of functions says that you're just going to differentiate each term separately. So I'm going to erase some of this. Okay, so I really have almost two separate derivative problems here, and I'm going to differentiate each of those, and then my answer will be the sum of those two derivatives. The other thing to notice is that on this first term, I have 5x squared times secant of x. So there's also some product rule in this first part here. So I'm going to be using product rule here. And then at the end here, I'll just need the derivative of tangent x, that's sum. Okay, so these little hints, this labeling, I really recommend that to help yourself not get lost in all the details of the problem. Okay, so I'm going to set this up like I did before for product rule. So y prime, or dy dx, equals, and then I'm going to set up some parentheses and label them here. Okay, so the derivative of the first times the second plus the first times the derivative of the second. That's for product rule on the part where I've labeled that we're going to need product rule. And then I'll have plus still that derivative of that last part of that derivative of tangent x. So I'm going to put a plus there just so I don't forget to come back and do that. Okay, and here now I'm just going to go ahead and kind of fill in my parentheses and fill in my derivative. Okay, so the derivative of the first function, derivative of 5x squared, that's the bring down the exponent, subtract 1 rule. Everybody's favorite rule because that's an easy one, times the second function, so I'm just going to leave that function alone, secant of x, plus, I'll darken that there so we don't forget it, the first function, that's my 5x squared, this is the first function in the product, times the derivative of the second. So I need to remember what that derivative is, and I probably need a little more space there than I left for that parentheses, because the derivative of secant is actually a little bit longer than some of these other ones, right? That is secant x times tangent x. So those need to be memorized. Okay, and then I put this plus here so that I wouldn't forget that I also have a derivative of tangent of x that I need to find here at the end. So derivative of tangent x is secant squared x. Alright, so at that point, if I type that with all those parentheses and those pluses, or if I write that down, that's a correct derivative. If I want to tidy that up a little bit, there's a couple things I could do. I could start by just removing some of these unnecessary parentheses. So the first term would be 10x times secant x. The next term would be 5x squared secant x tangent x. And then the last term would be secant squared of x. So I could leave it like that. I actually probably would leave it like that. Another thing, sometimes students like to factor out common factors, and that's perfectly fine. If you want to do that, you just need to make sure that you're not making a mistake when you do some extra algebra. Alright, so in this first term I would be left with 10x. In the second term I would be left with 5x squared times tangent x. And in the last term, I would just be left with secant of x. Okay, so that's fine too. Don't forget the secant out front. One other thing I want to mention about this that's a big deal. Remember, I've said this several times. The original function, that's my y. And then what I have here is the derivative, and they are not the same. So sometimes I see students just write the original function and then equals and then what I have in the box here, which is not correct. Original function and derivative, they are not the same. So especially the farther you go in math, the more important that will be.